So let's get started. We are going to solve the most famous problem of the LeetCode, that is to sum. So let's first try to understand the problem clearly. As we can see, we have been given an array of integers and an integer target. We have to return indices. We have to return indices of the two numbers such that they add up to target. So we have been given an array of integers and an integer target. We have to return indices of the two numbers such that they add up to target. I think the most important thing that we need to take as note here is that we have to return indices of the two numbers. We do not have to return the two numbers. We have to return the indices of them respectively. So now let's try to understand it here clearly. Why I'm saying that this is the most important thing to note. Let's understand it first. So suppose if we have been given an array, okay, suppose if we have been given an array like 7, 5, 8, 4, 9. Suppose this is the array that we have been given, then their indices will be 0, 1, 2, 3 and 4. Now if we sort this array, then what we will get? We will get something, we will get 5, 4, 7, 8 and 9 after sorting, and their indices will be 0, 1, 2, 3, 4. Now if we look at carefully, then here at index 0 we have 7. So 7, index of element 7 is 0. But if we look at the array after the sorting, sorted array, then our 7 is at index number 2. Originally it was at index 0, but after the sorting the 7 is at index 2. And similarly if we look at 5, which is at index 1, but after sorting it is at index 1. So okay, this is okay. But if we look at something like element 8, so now if we look at element 8, it before sorting originally it was at index number 2, but after the sorting it was at index number 3. So what is happening here? As we sorted the array, the order of element or the position of element gets changed, because of which we lost the original indexes of each element. 4 was at index number 3, but as we sorted the array, now the 4 is at index number 0. So we lost the original position of the element. Why the index matters here? Because we have been told in question that we need to return the indices of the two numbers, but we are changing the indices here. So the original indices or the original positions of each element got changed or modified. That's why if we return the indices, in that case, if we return the indices of the sorted array, then it will be wrong. The answer will be wrong because the original or actual indices is different from the sorted array. Okay, now let's try to understand the examples here. As we can see, we have been given an array and we have elements like 2, 7, 11 and 15. So what we and the target is 9. So what we need, we need to find the two elements whose sum equals to the target. So as we can see here, the two element will be 2 and 7, which is 2 plus 1 equals to 9, and the target is also 9. So in the indexes of 2 and 7 is 0 and 1, so we return as 0 1. Okay, so similarly here as we can see, we get 2 plus 4 6, so indexes of which will be 1 and 2, so 1 and 2 is the answer. Similarly here the indices will be 0 and 1 for example number 3. So by looking at the examples, the first and obvious approach which is coming to my mind, or which will come to most of us mind, is that why not take two pointers. Suppose if we have arrays like 1 9 11 6 4, and we have to find 12, as our target is 12. Why not we take two pointers? Suppose one is at the 0th index and another is at the 1th index. So this is indexes 1 0 1 2 3 and 4. So why not take two pointers, and first we'll start at first we'll start uh, from position 0, from index 0, and the second will start from a position greater than that, and they will check if I element at I, that is 1, plus element at j, that is 9. Okay, this is 9, element at I plus element at j, that is 10, which is equals to 12 or not. If it is 12, then we will return the answer. If it is not equals to the target, then we will move it. So what I am thinking, that for each I we will check every element before it. So for each I uh, we will check if for I at index 0, we will check if 9 plus 1 is equals to 12 or not, or if it is not 12, then we will increment the j. Then again we will check if 1 plus 11 is 12 or not. If it is 12, we will return, or if it is not 12, then we will increment again. So why not to check for each I? And suppose if we do not find, suppose if the target is not 12, if the target is something like 19, element uh, pointed by I, which is currently 1, and if element pointed by j, which is 9, are their sum equals to 19 or not? They are not equal, because is it sum 1 plus 9 equals to 10. So we will increment j by 1, and we will again check if 1 plus 11 is 19 or not. It is not 19. Again we will increment j, and we will check if 1 plus 6 is 19 or not. It is not, because 1 plus 6 equal to 7, and we will increment j again, and we will check if 1 plus 4, that is 5, which is not equals to 19. So we will again increment j, and since we are out of the array, that's why we will increment I this time, because we iterated over the whole array. Now it will increment I, and we will check if I plus now we will check if I plus, and for this I also we will iterate over each element ahead of it. Okay, so I is pointing at index number 1, so we will start, so j will start from index number 2. So for now we will check if the sum of these two elements are equals to 19 or not. 9 plus 11 is 20, so which is not equals to 19. So we will again move ahead, and we will check if 9 plus 6. So we will increment j. We are incrementing or iterating j for each I. For each I in the array, we are iterating j over the array. So one question that can come to our mind is, why not we starting j from the start index, that is index from index 0? Why we are only starting iterating j from one element ahead of I? Why we are starting from index 2? As I is at index 1, why we are not starting j from index 0? Why we are starting from the position ahead of I, that is I is at 1, so 1 plus 1 equals to 2. So why we are starting from 2? Why not starting from 0? So when we are at 1, when the I is at 0, we already checked this combination. We already checked the pair, that is 1 and 9, and we do not get the answer because 1 plus 9 equals to 10, but our target is 19. So we do not got the answer. By the way, this is 19. Okay, this is 19. So this pair, that is 1 and 9, got checked once. So now when the I as is at index 1, and if we start the j from the index 0, then see, we again got the same combination or same pair, that is 1 and 9, which is again the same pair that we checked earlier. So this is checked already. When I was at this index, the j was at this index. So again starting j from the start does not make sense, because we will get same pair again and again. So that's why we are starting start j from I plus 1 position, that is if I is at 1, then j will start from 1 plus 1, that is at from 2. So for I equals to 1, that is index 1, we will check j. So 9 plus 11 20, which is not equals to 19. We increment j. 9 plus 6 is 18, which is not equals to 19. We again increment j. 9 plus 4, which is equals to 13, which is not equals to 19. And we will again increment j, and it will get out of the array. So when it gets out of the array, that means it's time to increment our I. So we will increment I by 1, and for I at index 2, we will again iterate over the remaining array using the j pointer. So j will start from I plus 1, that is I is at index 2, so j will start from or start at index I 2 plus 1, that is 3. So now we will check if 11 plus 6 equals to 19. It is not equals to 19 because it is equal to 17. So again we will increment j, and we will check if 11 plus 4 is equals to 19. It is not, because it's equal to 15. So we will again increment j, and since it is again out of the array, we will move the increment or move or increment the I pointer by 1, and then we will place the j pointer at the position I plus 1, that is currently I is at index 3. So we will put j at index 3 plus 1, that is at index 4. So we will check again if 6 plus 4 is equals to 19. It is not, so we will increment j, but we got out of the array. So now we will increment I once again, and we will start from I plus 1 position, but I plus 1 position is out of the index, so it will again fail, and we will again increment the j, and it also goes out of the array, and we got do not got anything. So if we do not get anything, we have to return the empty array. So we will return the empty array. So this is the method, this is the approach that we can think, and that is very intuitive to come to our mind. So let's see its pseudocode. Its pseudocode is pretty much simple. Okay, we have to iterate. First we have to iterate the array from which we will going to do using I pointer, which will starts from 0 and goes to 0 to n, where n is the length of the array. Let's say it nums dot length, and since indexing of array starts from 0, that's why we need to minus it by 1, basic stuff. And inside this iteration we have to, and for each of these iteration we have to iterate another loop, iterate over another loop using the j pointer, and which will starts from I plus 1. Okay, which will start from I plus 1, and it will go till n minus 1, same. And inside it we will check if nums I plus nums j is equals to the target or not. If it is equals to the target, then we will return a new array, basically new array. Okay, return a new array with the indices I and j. This is the situation when we find the target or find the required answer. So this is the if condition, this is the loop, this is the outer loop, and if we do not find the answer, then at last we return a new empty array. Okay, this is the empty array we will return. So this is the first approach so that we can think of. So let me write the code for you. So we will start with a loop, and here we will iterate it using the pointer which I will name as I, and it will check for the condition if I is less than nums dot length or not, and if it is less than the length of the array, then only go inside this loop, and we will increment each I each time at the end of the loop. And inside it we are going to have another loop, that is which will iterate using the pointer which we called as j, and j will start from I plus 1. Starting position of j will be I plus 1, and we will again check for the condition if the j is less than nums is less than the length of the array or not. So it should be less than the length of the array to enter the loop, and we will again increment the j at last. And here we will check if the element at position I plus the element at position j is equals to the target or not. If it is equals to the target, then we will return a new array. Okay, we will return the new array here with I and j. So, and after that, if we and after at last, if we do not get the answer, the required answer, then we will say we will return a array and an empty array. Basically we will return an empty array. So I think this will work. So what will be the time complexity of it? The time complexity will be O of n square. Why O of n square? Because we are using a loop here. So we are using a loop inside we are using one loop inside the another loop. So because of that, the time complexity is O of n square, because each loop is dependent on the length of the array. So bigger the array, more time it will take to iterate over the elements of the array. We can say that this is not that much efficient way, but it does its job. In the next video we will try to enhance it.